Hello students. In this lecture we are going to start our fybsc paper 2. The code for this paper is EL122. The name of the paper is Analog and Digital Device Application. Alright. So in this lecture we are going to start with the chapter number 1, which is operational amplifier. So we are going to see each and everything basic details about the operational amplifier. So it is going to be a very small and very interesting chapter. So I'll try to clear all your basic concepts related to the operational amplifier in this chapter. Alright, so while we are studying for the operational amplifier, first go with the introduction. What is it, why it is used, and what are its applications. Alright, so the first thing is that an operational amplifier, it is also called as a op-amp. Abbreviation of operational amplifier is op-amp. In shortcut, we can just call it as a op-amp. Okay, so it is a voltage amplifier usually consisting of a one or more differential amplifiers and usually followed by a level translator and the output stage. Alright, so operational amplifier, as its name indicate, amplifier means what? It is going to amplify the input. No matter which kind of input you are going to give to it, it will amplify that input and produce the output. Now what is the meaning of amplify input? It will increase the strength of the signal, okay, or amplitude of the signal. Alright, and now why operational? Alright, because this operational amplifier is able to perform all kinds of mathematical operations. Okay, for example, addition, subtraction, multiplication, division, integration, differentiation, all such kind of mathematical operation can be done with the help of this op amp. That is why it is called as a operational amplifier. Alright, the input stage is a differential amplifier which determines the input characteristics of op amp. At the input, it is going to have a differential amplifier, and that differential amplifier determines the input characteristics of op amp. In most operational amplifier, the output is single-ended. So you are going to get only single-ended output in most kind of op amp. After that, op amp is available as a single IC package. So operational amplifier is a IC. The number of IC is IC741. Okay, so it is available in a single IC package. The operational amplifier is a versatile device that can be used to amplify DC as well as AC input signal. Now, if you apply a DC signal or AC signal, op amp is going to amplify that signal. Okay, after that, operational amplifier are some of the most basic active components in analog system. Now, what is active components? Active means it is going to require some kind of external supply for its working. Okay, op amp require external supply for its working. That is why it is called as an active component. And whatever active components we have, out of them, this is going to be a very most basic component from analog system. Okay, by connecting suitable external components in feedback path, maybe that is resistor, capacitor, transistor, etc., whatever it is, so it can be used for variety of applications. Depending on which kind of component you are connected in feedback, the type of application or application of op amp can be changed. Now, operational amplifier are widely used for analog computation, and although techniques are being suppressed by digital methods in computer engineering, the range of application for op amp in instrumentation and control system engineering are rapidly expanding. So basic thing is that currently also op amp is in market and it is widely used. That is why we are studying it. Okay. Now we need to understand some basic ideas about the op amp and what are the ideal characteristics of op amp. What is ideal op amp? What is practical op amp? We need to understand too many things. Okay. We will start with the basic and ideal operational amplifier. First thing is that definition. I have already told you. Operational amplifier means what? It is oftenly called as op amp or op amp. Okay. It is a DC coupled high gain electronic voltage amplifier with a differential input and usually a single ended output. Instead of this, you can just also call it as it is a operational amplifier is an amplifier which is able to perform all kinds of mathematical operations. Okay. Now, basic and ideal op amp has the following properties. What is basic and what basic and ideal op amp we have? It have following properties. First thing is that infinite gain. It is a ideal characteristics of op amp. It is going to have a infinite gain. Correct. What is gain? Output quantity divided by input quantity. That ratio should be infinite in case of op amp. Okay. After that, second property is infinite input impedance. So we have first thing as an infinite gain, second infinite input impedance, third infinite bandwidth, fourth zero output impedance. Input impedance was infinite, but output impedance is zero. After that, zero voltage and current offset. What we have else? First three things for infinite gain, infinite input impedance, infinite bandwidth. Next we have zero output impedance and zero voltage and current offset. Okay, but a practical op amp has voltage gain in excess of 2 mega, input impedance greater than 1 mega ohm, bandwidth greater than 1 megahertz, and voltage offset in millivolt range. So but the whatever I just told you, these are the characteristics of ideal op amp. Ideally it should be like this, but practically whenever we are starting the whenever we are doing the practical, I the numbers are not exactly similar. Okay, so basically ideal parameters are quite different and practical parameters are quite different. Next to that, we need to study a block diagram of op amp. Like whenever we are studying any kind of electronic circuit, we usually understood the black block diagram of it first. Here also, to understand op amp, we should aware of the block diagram. The first, there are like total four blocks. First block is all about input stage. Okay, it is also called as a differential amplifier. So it have two inputs. As you can see in the diagram, input stage have two inputs and it is producing two outputs as well. Correct? Those two outputs of input stage are connected to the intermediate stage. Right? Intermediate stage is again going to have two inputs, but it is going to produce a single output. After that, that single output is connected as an input to the level shifting stage. Correct? Level shifting stage is also going to produce a single output, and that is provided to the class B push-pull emitter amplifier. Okay, and that class B push-pull emitter amplifier or follower, it will produce the final output voltage. Correct? So this is how the block diagram of op amp is. The first thing is that we need to understand each and every block in detail. In the first stage, the input stage provides most of the voltage gain of amplifier, which determines the input characteristics of op amp. So whatever the first or input stage or a differential amplifier stage we have, that determines the input characteristics. Okay. Secondly, we have intermediate stage. It usually another differential amplifier which is driven by the output of first stage. Obviously, the second stage is having input which is output of previous state. So that is why we can call it as a, it is driven by the output of first stage. In most amplifier, the intermediate stage is dual input single output. Now we know dual input, what does that mean? It have two inputs and single output. Correct? Due to the direct coupling, the DC voltage at the output of intermediate stage is above the ground potential. Therefore, generally level transistor or level shifting circuit is used to shift the DC level at the output of intermediate stage, download to 0 volt with respect to ground. Okay. Next, we have a final stage in which we have class B push-pull emitter follower. It is a complementary amplifier output stage. The output stage increases the output voltage swing and rises the current supplying capability of the op amp. What is the function of last stage? It usually increases the output voltage swing and it raises the current supplying capability of op amp. Alright, so this is all about the four blocks. In most operational amplifier, the output is single-ended. Okay, output obviously it is going to have a single ended with positive and negative supply. The single ended output is designed to have a quiescent value of 0. So Q point should be 0. This way 0 input voltage ideally results in a 0 output voltage. After that, as you can see, this is what is the functional block diagram. We have seen a block diagram over here. This is the block diagram of op amp. Now we have to see the functional block diagram. Okay, we don't want to go in detail what is there. There are multiple transistors. Okay, this is what is your first stage. Okay, this dotted line and this dotted line. In between these two dotted line, there is a differential amplifier stage, that is first stage. Okay, output of first stage is given to the input to the second stage, that is amplifying. Transistor is used for amplification. So output of this second stage is given to the final stage. Correct? So this is how your functional block diagram of op amp look like. Nobody is going to ask you to draw this diagram, but for your understanding or for more information, you should be aware of the functional block diagram. After that, symbol and equivalent circuit of op amp. This is going to be very important. Always remember what is the symbol. So this is how the symbol of op amp is drawn. There is a triangle which have two inputs, inverting input and non-inverting. Inverting is always denoted by negative symbol, and non-inverting is always denoted by the positive symbol. Okay, there is a single ended output, and it contains, as it is a active device, it will have a power supply. Correct. So this is plus VCC minus VE. So always remember this. This is going to be very, very, very important. Star mark to it. All right. After that, this is the equivalent circuit of op amp. What is this? There are two inputs. We have two inputs to the primary stage. After that, there is a input impedance matching. There is a differentiation between V1 and V2. These two inputs, V1, V2, multiplied by the gain, and we are going to get the final output. All right. So this is how equivalent diagram or equivalent circuit diagram of op amp will look like. After that, we have ideal and practical characteristics of op amp. Okay. So what is ideal character? What are the ideal characteristics and what are the practical? Obviously, there should be a difference. There is a difference. Ideal means some ideal value, but practically, whenever we implement that, it should not be same as that of your ideal value. Okay. Practically, we like see the changes. Now, what are those changes? The first thing is that ideal characteristics of op amp. The first is your input offset current. Okay, see this diagram. This is the op amp, inverting terminal, non-inverting terminal. Always remember, negative means inverting, positive means non-inverting. Correct? So IB1 and IB2 are the currents flowing through the inverting and non-inverting terminal. So what is IB1? The current flowing through inverting, and what is IB2? Current flowing through non-inverting. Then the difference between currents of balance amplifier is called as input offset current. So IB2 minus IB1 is called as a input offset current. We have two terminals of op amp. If we apply signal to the both the terminals, then current will flow from both terminals. Correct. And the difference between these two current is called as a input offset current. Okay. So it is written as input offset current is equal to IB1 minus IB2 at V out is equal to 0. Okay. The next is input bias current. What is input bias current? So it is a if IB1 and IB2 are current flowing through the terminals of op amp, then average value of the current when V out is 0 is called as input bias current. Suppose we have two different current which are flowing through the two different terminals of op amp, then whatever is the average value of these two current is called as your input bias current. But the condition is that whenever you are calculating input bias current, your output should be 0. See here, IB1, IB2 are my two different currents. What is how to calculate average? Add them divided by 2. Okay, so this is how input bias current can be calculated. The next one is your input offset current drift. It is defined as a ratio of the change in input offset current to the change of temperature. Okay, so as the temperature changes, there will be a change in input offset current. So ratio of these two is nothing but your input offset current drift, and it is denoted by a ratio of change in input offset current divided by change in temperature. All right. So next one is your input offset current voltage. What is input offset voltage? It is a difference between voltage at the input terminal of balanced amplifier. That is to get the output voltage required to provide zero output voltage with the zero input signal. What is it? Consider, suppose we are not giving any kind of input, right? So at that time, your output should be zero, or whatever input you are providing at V1 and V2 two terminals, that difference of them should be equal to 0. Okay. After that, input offset voltage drift. We have seen what is input offset voltage. Now input offset voltage drift. It is defined as the ratio of change in input offset voltage to the change in temperature. Similarly, instead of current offset drift, we have voltage offset drift. What is current? Change in input offset current. Here change in input offset voltage divided by change in temperature. Correct. Next one we have input common mode range. It is the maximum range of input voltage which can be simultaneously applied to the both the input terminals without causing saturation. So what is the maximum? See, in electronics every device has its maximum and minimum capacity. Similarly, op amp is also going to have its maximum capacity. So what is the maximum voltage I can apply to the terminals of op-amp, that is called as your input common mode range. Okay. So next one is your input differential mode range. It is the maximum difference signals that can be applied safely to the op-amp input terminals. What is the maximum difference we are applying to the input terminals is called as a input differential mode range. Next one is your input resistance, that is in differential case. It is the effective resistance between two input terminals when operated open loop, when operated at open loop. Now, if we are using our operational amplifier in open loop, then what is the effective resistance between two input terminals? That is called as a input resistance or resistance offered by an input terminal. Simple. Okay. Next one is your output offset voltage. When the voltage applied at the input terminals are grounded, that is V1 and V2 are equal to 0. We are not providing supply to the any of the signal or any of the terminal. Both the terminals are connected to the ground. In that case, the voltage appearing at output terminal is called as a output offset voltage. See, if you're not applying any input, still you're getting some output. That is wrong, no? You're not even applying single bit of unit at the input, but still you get out, still you are going to get a output. And that is called as a output offset voltage. Okay. So next one is your output voltage range, maximum output swing that can be obtained by a significance distortion. Now, what is the maximum range of that operational amplifier that it can produce a voltage? That is called as output voltage range. Full power bandwidth, the maximum frequency over which your output swing can be obtained. So what is the maximum frequency you can apply to the op amp? Is called as a full power bandwidth. Output resistance, a resistance offered by an output terminal. Okay. Input impedance, this is important. Z in. Okay, it is always denoted by a Z in. Input impedance is the impedance, it can be like defined as it is a ratio of input voltage to the input current. Okay, ratio of input voltage divided by input current. Next one is your, like, ideally input impedance should be infinite. Output impedance, the output impedance of op amp is assumed to be 0 and acting as a perfect internal voltage source with a no internal resistance, so that it can supply as much current as necessary to the load. Whatever is the requirement of load, that op amp should provide that much of sufficient voltage to the load. Next one is your power supply rejection ratio, PSRR. Power supply rejection ratio. It is defined as it is a ratio of input offset voltage to the power supply, change in power supply. Correct. It is a ratio of change in input offset voltage divided by change in power supply. This definition is also going to be important. For 1 mark, they can ask you this: what is PSRR, or define PSRR. The next one is your CMRR, common mode rejection ratio. This is again going to be important. They can ask you a MCQ or one line question on this. CMRR, common mode rejection ratio. Now it is defined as it is a ratio of differential mode gain divided by common mode gain. It is written as modulus of AD upon AC. What is AD? It is a differential mode gain. And what is AC? It is a common mode gain. After that, we have a slew rate. What is slew rate? This is also important. Mark it. The slew rate is the rate of change of the closed loop amplifier output voltage per unit time under the large signal condition. Slew rate is defined as output voltage change per time. Okay. So these are the characteristics of op amp. Now we'll see those characteristics in tabular format. Whatever we have seen till now, we'll see that in the table format. The first characteristics is open loop voltage gain. What is open loop voltage gain? It is denoted by a symbol AOL. In future, even like whenever you are going to see this AOL, it is read how you are going to read it: open loop voltage gain. Correct. And its ideal value should be infinite. Next, input impedance. Impedance is always denoted by Z. As it is input impedance, IN is there. Input impedance, it is also infinite. Output impedance. Now impedance is again defined by Z, and as it is output impedance, it is denoted by 0. Its ideal value should be 0. Offset voltage, VOS. It is ideal value should be 0. Bandwidth is denoted by BW. It should be infinite. CMRR is denoted by the symbol sigma. Okay. And its ideal value should be infinite. Slew rate, SR, infinite. PSRR, power supply rejection ratio, It should be ideally 0. All right. If you memorize this chart, you will be able to understand, or you will be able to write all the questions which are related to the ideal and practical characteristics of op amp. So this is ideal. Okay, whatever we have seen right now is the ideal characteristics. Now we need to see the practical also. Correct. Now this table will summarize the ideal as well as practical characteristics. See here, there is a parameter, the symbol, ideal value and typical or practical value of IC741. I have told you what is this IC741. It is an operational amplifier IC. Correct. So if you go through this chart, I'm going to pause it over here for a few seconds. So if you go through this chart, what we will observe? You will observe all the parameters, its symbol, its ideal value and its practical value for IC741. All right. So just go through this once and you will be able to answer all the questions. All right. So in the next lecture, we will see the remaining things.